So here we have the E1 reaction mechanism. This is an elimination again. If you looked at E2, and we're going to end up with a double bond and alkene as our product by only removing things. So in general, a molecule that can, or any reactant that can do E1 has to have some sort of leaving group and reacting with a base. E1 happens to be weak base, but the first step is just like SN1. First step is always leaving group coming off. So in this case, we'll have a carbocation. So when you have that, you always got to think, is this going to rearrange? Not in our simple example, but very possible to. So we'll have a carbocation, and then the base comes in, takes the hydrogen, leaves the electrons behind to form the double bond, right? So those electrons go and form this pi bond. Hydrogen is gone here, right? So it's a two-step version, with an intermediate, otherwise very, very similar to E2, right? Governed by different rules and some different products and details. But the arrow pattern, bond breaks, eliminate a hydrogen, form a double bond. So for our real example, this molecule will act the same. So first step of an E1 is again just the leaving group coming off. So we'll form a carbocation in this position. Right? Our base is water, but it's not active in the first step. Right? So now we have a carbocation, and so from either of these two positions on the neighboring carbons, we can take the hydrogen. They're equivalent in this case. It doesn't make any difference. So our base is going to take that, eliminate to form the alkene. So again, we had an intermediate in this reaction. It couldn't rearrange in this case because all the positions were identical, so there's no way to make things more favorable. But that gives us our carbocation intermediate and then our alkene in the end.